Welcome to The Explainer. Today, we're diving straight into one of the most mind-bending concepts in all of science. We're pulling from the insights of theoretical physicist Michio Kaku to explore physics' absolute greatest mystery. And specifically, we're going to look at exactly why the mathematical hunt for ultimate unification points us directly towards the existence of a multiverse. If you've ever wondered how the fundamental building blocks of reality actually tie together, and how that very math might spawn entirely new universes, well, you're in the exact right place. Let's get right into it. Section 1. The Ultimate Physics Quest. Michio Kaku poses this really brilliant question. What is the mind of God that Albert Einstein chased after for 30 years of his life? For his last 3 decades, Einstein wasn't just resting on the laurels of relativity. He was desperately searching for an elegant way to unify the 4 fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. He wanted to tie them all up into one beautiful single theory. And that brings us to the concept of the God equation. This is a proposed final theory of everything in physics that unifies all 4 of those fundamental forces into one single equation. Now, this isn't just some mathematical abstraction. Leonard Euler, the legendary mathematician, had a God equation of math: 1 plus e to the I pi equals 0. It's incredibly beautiful. It perfectly summarizes fundamental constants. But as Kaku points out, it's essentially useless for practical application. A God equation for physics, on the other hand, would completely summarize the fundamental constants of our actual universe. It would literally be a blueprint for reality itself. Section 2. Past revolutions in physics. To understand the stakes here, just look at the track record. Every single time physics unraveled and united a new force, it completely changed human history. Newton's mechanics? That sparked the Industrial Revolution. Maxwell's electromagnetism brought us the electric revolution. And Einstein paved the way for nuclear power. Each time we unravel a force, it sparks a massive technological revolution. So just imagine the phenomenal leap forward humanity would take if we could finally unify all of them at once. Section 3. The Great Physics Divide. So what's the holdup? Well, we basically have 2 great pillars of physics currently at war with each other. On one side, you've got general relativity, Einstein's philosophy, which is based entirely on continuous, smooth curves of spacetime. But on the other side, you have quantum theory, which governs the microscopic world by chopping reality up into discrete individual particles. And here is the core problem. You cannot easily mesh smooth, flowing curves with a chunky, discrete reality. The mathematics literally fight each other. That clash is the great divide in modern physics. Section 4. Enter string theory. To understand string theory's solution to this epic clash, we first have to look at the old quantum perspective. If we view electrons, neutrinos, and quarks from a distance, they basically just look like tiny dot particles. So ask yourself, how many of these fundamental dot particles actually make up the universe? Hundreds. Literally hundreds. Scientists smashing atoms together in colliders have found hundreds of these so-called fundamental dots. And honestly, it makes the standard model of the universe look incredibly chaotic, cluttered, and quite frankly, ugly. It certainly doesn't look like an elegant mind of God. But string theory completely cleans up that mess. If you peer deep down into the heart of an electron, string theory says it's not a dot at all. It's actually a tiny, vibrating rubber band, very much like a guitar string. And just as different vibrations on a guitar string create different musical notes, different vibrations of these microscopic strings correspond to different subatomic particles. It encapsulates the entire universe with one simple, beautiful symmetry. Every single particle is just a different note played on the exact same string. And here's the kicker. If these strings can vibrate to create our known particles, their incredibly complex mathematics might also allow for entirely different configurations of reality. Section 5. The math checks out. Kaku really hits the nail on the head here when he says, so far with string theory, 2 plus 2 always is 4. Because here's the thing, if you take all the other competing theories of everything and probe them far enough, the math eventually breaks down. You literally end up proving that 2 plus 2 equals 5. The theories become mathematically inconsistent and just fall apart. But string theory, the math remains perfectly, rigorously sound. It holds together against the toughest mathematical scrutiny. Now, we absolutely must acknowledge the elephant in the room. The main objection to string theory right now is simply that we cannot directly test it yet. These strings are just unfathomably small. But physicists are getting closer and closer to verifying its mathematical predictions. Science is catching up. Section 6. Welcome to the multiverse. And when the math of string theory finally works out to unite relativity and quantum mechanics, it completely opens the door to the twilight zone. Because if reality is made of vibrating strings in hyperspace, the equations suddenly allow for things like time machines, wormholes, and even glimpses of the universe before the Big Bang. But most importantly for us today, it mathematically predicts the multiverse. See, the math of string theory actually requires extra dimensions to work, 10 or 11 dimensions in fact. And depending on exactly how those extra dimensions fold up, you get entirely different physical laws. It strongly suggests our universe is just one mathematical solution. Basically, one single bubble in an endless, boiling bath of multiverse bubbles, with each one playing its own unique cosmic symphony. So we end on this truly profound thought. Can you go backward in time and meet your parents before you were born? Can we one day traverse the multiverse, or maybe travel faster than light through a wormhole? Look, we don't have the final answers yet, and honestly, that is exactly what you should take away from this explainer. We need string theory to keep pushing those boundaries, to keep exploring these mind-bending, reality-altering possibilities, and to finally, once and for all, decode the mind of God. So are you ready to see where the math takes us next?